In this example, we have a little bit of a unique situation where when we go to factor the denominator, it's got just a 2x squared. It's not factorable. And then our point of discontinuity, we get 2x squared. We set that equal to 0. When we go to solve, you could divide by 2 and then get x squared equals 0, and then, follow through the square root method, get a plus or minus 0, but ultimately it comes down to 0 can't equal x. Because if I plugged in 0 here, I would have a division of 0 scenario, and I can't divide by 0. So I got to decipher whether that's a vertical asymptote or whole by following through the rest of our process. We need to factor the numerator. This time the numerator has a greatest common factor of negative 5x. So when I do that, I get negative 5x times x plus 2. If I rewrite the denominator, just sliding it on over, I get 2x squared. And so now that I factored my numerator, I can reduce. When I reduce, I'll be able to decipher what this 0 was. And I have to do so carefully, tread lightly. When I divide my x, because that is in common, I have an x on the top and I had 2x on the bottom. 1 from the top cancels, 1 on the bottom cancels, and I'm left with negative 5 times x plus 2 all over 2x. So yes, a x reduced out, but be careful, it reduced out, but not completely. It still remains. Whenever they remain, even though part of it reduced, it looked like it started to reduce, you have a vertical asymptote. This result, if it remained, is a vertical asymptote. So I go down to the whole and I cross it out because there are no other points of discontinuity. There is just my vertical asymptote, and that's when x equals 0. So that's what this result means. That was a little bit of a trickier one for a lot of my students. Now, when we set the numerator equal to 0, to continue the process, we say negative 5 times x plus 2 equals 0. This is another tricky spot for a lot of students. A lot of students see that negative 5 and say that that is a 0. It is not. If you set negative 5 equal to 0, you should say that's not true. So don't say it is, and don't say that's an x-intercept. What you should do is divide negative 5 from both sides and make it disappear. And really, you're just working with x plus 2 equals 0 and solving and getting x equals negative 2 as your x-intercept. So x-intercept is the coordinate negative 2, and we were setting it equal to 0, so the y height is 0. That's the x-intercept. To find the y-intercept, step 5, we need to find f of 0 in the reduced version. So we're going to take the reduced version, plug in 0. So negative 5 times 0 plus 2 over 2 times 0. Oh, wait a second. Didn't we say that you can't do that? Yes, we did. So this result right here was undefined, which means there is no y-intercept. Because right here, when your vertical asymptote is the vertical line x equals 0, that means the y-axis does not have any values. And so we cross that line out because we cannot have a y-intercept if our vertical asymptote is the y-axis. To finish the problem, we just have to identify our horizontal asymptote using one of our 3 rules, and that's all based on degree. So we look at the degree of the top and the bottom, whether it's the beginning or the end. The degree of the top and bottom is the same, and so all you do is divide your a values, and that will be your y equals negative 5 halves. So the y equals negative 5 halves is your rule for the horizontal asymptote based on the fact that the degree of the top and bottom were the same. So negative 5 halves. And now we have found all 5, well, it turns out to be 3 of the 5 key features for this rational function.